Okay, today we're just going to be going over some of the common functions. Now notice I said going over, so you guys should be somewhat familiar with some of these common functions, if not all of them. Now keep in mind, these are common functions necessary to sort of understand and have, engraved into your head before stepping into an Algebra 2 classroom. Now, it's really just important to understand these uh, common functions so that you won't sort of get confused once you enter the Algebra 2 classroom. Because I'm sure that your teacher will expect you to at least, have a good or just somewhat, you should be somewhat comfortable and just have a good understanding of each of these common functions. Now keep in mind, when we go over the domain and range of these functions, I am going to be doing it in interval notation. The reason is because when I specifically studied, when I did Algebra 2, we were expected to put our domain and range in interval notation. And of course, when you get into pre-calc, you'll have to do the same thing. So I guess, I mean, I'm just assuming that everyone else, usually even most Algebra 2 textbooks that I've seen, they always put the domain and range in interval notation. So I guess most curriculums may require you to put your domain and range in interval notation, so I'm just going to follow that. Now, if I go over functions that you have, or if I didn't go over a function that you learned sort of in Algebra 2 or were like expected to, in Algebra 1, right, I'm going over functions that you've studied in Algebra 1. If I went over a function that you studied in Algebra 1, but I didn't cover it in this video, that's probably because it's not covered in most Algebra 1 curriculums, because I'm just going over common functions that you sort of have to be comfortable with in terms of most Algebra 2 curriculums and like what has been covered in most Algebra 1 curriculums. So in Algebra 1, if you studied like log functions, trig functions, rational functions, stuff in that nature, then go watch another one of my videos, which will be coming in the future. Let's get started here. And I'm going to start off with probably the most fundamental function that you need to know, which is this one, the linear parent function, y equals to x. Now, take a minute here. How do you think the function is going to look using your prior knowledge? You should hopefully have like a general picture, like that this is a blank function, right? Hopefully you know what type of function it is and the sort of shape of the function or just how it looks on the coordinate plane. Okay, so the blank is the linear, right? It is a linear function. Okay, so it looks somewhat like this. This is not drawn to scale, but this is what it looks like. It intersects with 0, 0. And in terms of our domain, remember I'm going to write an interval notation. We know that it's all real numbers. Now, how do we write all real numbers in interval notation? Remember, it's negative infinity to infinity. Now, remember, we don't put these square brackets. We don't do this. Okay, we cannot do this, perhaps. We cannot. Now, why do you think so? Well, it's because infinity, we cannot specifically include infinity, right? Because the square brackets imply that we include a value, and infinity is not a defined value, so therefore we can't include infinity. So this is all real numbers written in interval notation, and a range is also all real numbers. So for a range, it's also negative infinity to infinity. So yeah, just sort of understanding why is it this. Well, let's think of like y equals to mx plus b, right? Well, we know that m is the slope, and the slope equals to rise over run. So what does that sort of mean? Well, if you guys remember, let's think of this here. Y equals to x. Well, we know that's the same as y equals to 1 over 1 x, meaning that a rise is 1 and our run is 1. So we pick any point, we rise up 1 from that point, then we run 1. So just sort of thinking about that, another way of getting the slope is, of course, with the formula m equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And just sort of thinking about how do we apply that formula, well, let's pick 2 points that belong into the function y equals to x. Well, let's just draw an xy table here. Now let's just plug in values. So let's say if x equals to 0, right, since y equals to x, y also has to equal to 0. Now let's think of this. If x equals to 1, then y also has to equal to 1 since y is equal to x. So now we have two coordinate pairs, 0, 0, and 1, 0, or sorry, 1, that's not a function if it was 1, 0, keep in mind. If you guys remember what defines a function. So yeah, that's my bad, and 1, 1. Okay, so now in terms of which one is x1, which one is y1, which one is x2, which one is y2, it really doesn't matter, right? We could set this to x1, this to y1, we could set this to x2, this to y2, or we could do vice versa. We could set this to x2, this to y2, this to x1, this to y1. We will still get the same m value either way. So let's just plug in values here. So then m, remember, so y2, 1 minus 0 over x2 minus x1, 1 minus 0, meaning that m would equal to 1 over 1, meaning that m would equal to 1. Okay, so hopefully you got that. So those are just two ways to find the slope. So just keep in mind, again, with domain and range, I forgot to mention here, domain implies the lowest x value, the highest x value. So in this case, since it's a continuous function as indicated by these arrows here, the lowest x value in this case, right, remember x value is from negative infinity, right, because it's continuous, then to positive infinity. And same with our y values here. Lowest y value, we know that's negative infinity, and then to positive infinity. So just thinking about that in terms of the graph. Of course, if you know that, oh, if you plug in any x value, you will always get a y value because it's all real numbers. Just thinking about that really helps you. Okay, the next function that I want to go over, which is you should have covered this one as well, which is y equal to the absolute value of x. So this is sort of after linear functions, you just get into absolute value functions. Now this is really easy to understand if you understand linear functions. So just think about it. What is sort of the shape of this function? I actually shouldn't have said, oh, this is an absolute value function. I should have made you guess that. But for the next function, I will make you guess, oh, what type of function this is. But in general, I just want you to think what sort of picture the function. What do you think the function is going to look like? Okay, so the function is supposed to look like this. Now, here's one thing to sort of notice here. We don't have any negative y values, and you're probably like, what y is that? Well, in general, thinking about the rules of absolute value, remember, absolute value, if we just draw a number line here, absolute value is the distance a number is from 0. So we have 0 here. Oh, what was that? Why is my marker doing that? So let's just say we have 0 here, and we have some number like negative 8. The distance from 0 to negative 8, the distance from 0 to negative 8 is positive 8, right? Because we know that a distance cannot be negative. You cannot say, I ran negative 28 miles today. I ran negative 28 miles today. We can never have a negative distance. In this case, absolute value must always equal to some positive value. So in this case, if, for example, we have absolute value of x in this case, right? If our y value was less than 0 when we inputted something, that's just impossible because the distance is always positive. So that's why our absolute value function does not include any negative y values. In fact, talking about a range here, the lowest y value is 0 because the absolute value can equal to 0, um, but because the rule implies that just absolute value cannot be a negative number. It cannot equal to a negative number. So just think about that. And the same is true for another type of function that we're going to go over in a bit. So, yeah, so we sort of got a head start here. Thinking about our domain here, we see that our domain is all real numbers, right? It's a continuous function as shown with the arrows. So we see here that x values go all the way from negative infinity to infinity. So the domain is all real numbers. And then a range here, like we just talked about, looking at the absolute value rules, the range is just 0 to infinity, including 0. Remember these, like we just talked about with the linear function, these square brackets show that the value is included. So including 0, from 0 to positive infinity, that's our y values. Our outputs are going to be in this interval. Okay, so we sort of got a head start here. I'm just going to indicate here this is 0, infinity, and this is negative infinity to infinity. Okay, so you can sort of think of it like this. We have a y equals to x here, and we have a y equals to negative x here, right? Because if we have the absolute value of x, think about this. If we have the absolute value of x equals to 7, we would have x equals to 7 and x equals to negative 7. So just thinking about that, we have y equals to positive x, we have y equals to negative x, but y cannot equal a negative value. So it's just two sort of linear functions, but they don't include, the y values can never be negative. Okay, so if you sort of understand linear functions, the absolute value function, and you just understand basic absolute value, like, oh, absolute value is the distance a number is from 0. Just understanding that, and that distances always have to be positive, absolute value is really easy to understand. Okay, so now we're going to be going over a function which is sort of similar in terms of the absolute value function. Now that is, you maybe studied this towards the end of Algebra 1, and that is the blank function, right? I'm not going to tell you what type of function it is. So I'm going to just draw the common function here. So just sort of think here, what is the sort of general shape of this function, and what is the general shape of the graph, and sort of what is it, what type of function is it? So just think about that. Okay, so this is a quadratic function. Now the shape is a parabola, so it looks something like this. Now, one thing you notice here, when I said it's similar to the absolute value function, it is, because we see that our lowest y value is in fact 0. In fact, our domain and range are the exact same. Right? Our domain is still all real numbers, and our range is also from 0 to infinity. Now, why is that? Well, let's think about this here. If we plug in, for example, if we have like an x and y table here. If we plug in negative 2, for example, and for x, so we have y equals to x squared. Well then, if we plug in negative 2 in for x, we get y equals to negative 2 squared. And what do we know about negative 2 squared? Well, we know that negative 2 squared, that equals to negative 2 times negative 2. And what is a negative times a negative? Well, it's a positive, so that means that negative 2 squared equals to positive 4. So if we apply the same logic to whenever we have a negative input, right? In this case, this is the negative part of the x-axis. We will always have a positive output. So that's why it is so similar to the absolute value function. In this case, why it has this sort of curve here, this parabola, and you'll get more into like parabolas, hyperbolas, stuff like that during Algebra 2 and like conic sections, stuff like that. But in terms of why it has this curve is because we're squaring the values. And because since we're squaring the values, we cannot have any negative output values. And then just in terms of the properties of the quadratic function, we know that the quadratic function, the standard form, like we talked about with the linear one, was y equals mx plus b. This is just y equals to ax squared plus bx plus c. So in this case, we see here that 0, 0 belongs onto our parabola. But in this case, 0, 0 is the vertex of the parabola. So how do we find the vertex from the equation? Well, hopefully you remember, well, if we have something in the form ax squared plus bx plus c, if we take negative b, the negative of our b value over 2a, that gives us the x-coordinate of our vertex. So then once we plug in our x-coordinate, then we will automatically get our y-coordinate. So just thinking about this, if we have y equals to x squared, we know that, right, we could rewrite that as y equals to, in the form of ax squared plus bx plus c is just x squared plus 0x plus 0. So in this case, applying negative b over 2a, that's just going to be negative 0, which is just 0, over 2 times 1, which is just 0 over 2, which is 0. So it means that our x-coordinate is 0, right? So we have 0, comma, then if we plug in 0 in for x, we get y equals to 0 squared, and 0 squared is 0, so y also has to equal to 0. So that just proves that our vertex is 0, 0. Now, if you were given the form of a quadratic, there's another form here, which is y equals to a times x minus h the whole squared plus k. Now this is called the vertex form of a quadratic function, where h comma k equals to the vertex, the coordinates of the vertex. So just thinking about that, if you were given a function in the form a times x minus h the whole squared plus k, do not expand it into the form ax squared plus bx plus c to find the vertex and do the whole negative b over 2a thing, because that's just a waste of time. Just acknowledging that h and k, right, that coordinate pair represents the vertex, can really just save time. And a way to obtain this form from ax squared plus bx plus c is you can use this method, negative b over 2a, or you can use another method called completing the square, which is another way to solve a quadratic equation, but it's a very uncommon method. Usually we try to factor or use the formula, and in some cases graphically, but mostly just factoring and using the formula. But completing the square is it's not common to use it solely for solving quadratic equations. So yeah, hopefully you get the sort of gist of quadratic, the common function, the vertex, or the properties of it, and how it's very similar to the absolute value function. And the reason why it has a curve is because we're squaring the x values, or our input values. Okay, now we're going to talk about the square root function. Oh my god, I did it again. I'm not supposed to say what type of function it is. So my bad. Okay, so I just gave you the answer. It's a square root function. But what I didn't give you the answer to is, what does it look like? So what does the function look like? So just take a guess, or hopefully remember, perhaps. What does this function look like? Okay, so the function looks like this, approximately. And you see here, in terms of our domain, we see that since this is 0, 0, oh, let me Could have done a better job on that arrow. Since this is 0, 0, we see here that our lowest x value is 0, highest x value is positive infinity, our lowest y value is 0, and our highest y value is positive infinity, meaning that our domain and range are equal to each other. 0 to infinity, and range is also 0 to infinity. Now, why is that? Just looking at it in terms of the analytically, we know that a square root can never equal a negative value, right? Because we talked about this earlier. If we have negative 5 squared, that negative times a negative is always a positive, right? So sort of if we get the square root of some value, our output can never equal a negative value. In fact, the lowest y value we'll get is 0. And also the lowest x value we can put is 0 as well. Because we put in the square root, well, if we plug in, right, we plug in -1, we would get the square root of -1, which is not a real number. And we're not going to get into imaginary numbers today. That's something you will get into in Algebra 2, like what is the square root of -1, which is I. But no need to confuse you now because that's not the main point of this. But just understanding that we would get a non-real output, meaning that that will not follow our domain restriction. And another thing, just a fun thing to sort of mention here, this, just looking at this function here, it sort of looks like a sideways parabola, except the negative y values are gone, and that's because in order to get this function, you need to restrict the domain. So we're not really going to talk about that, because that's more something that you'll talk about in Algebra 2. Okay, so that's basically it. I was going to go over the cubic functions, but I felt like there was sort of no need because you guys are going to go over like cubic, quartic, just polynomial functions itself mostly during your time in Algebra 2. So these are mostly just fundamental functions that you should have mastered already. So yeah, that's basically it. Please let me know in the comments if you have any questions or if I made a mistake in one of the problems, because I probably did. As you know, these videos are completely unscripted. I don't have a script for any of these videos. I just do these problems based off of just my thinking and nothing else. So anyways, thank you guys for watching, and I'll see you guys in the next one.